guys, welcome to this video lecture. And as you can see in the intro, we're going to tackle about laws of motion. Not just any law of motion, it's Newton's law of motion. But before we tackle every law, let's see what is the law of motion all about. They are described as the relationship between the forces of acting on a body and its motion due to forces. Not so easy, huh? But before we explain it further, let's have the first law, shall we? Inertia. If I say so myself, this is the easiest law in the Newton's law of motion. Why? Well, it doesn't have a formula. You don't need a calculator. And sometimes it doesn't have any numbers. Yeah, just reading a note. But there are two different definitions. That's sad, isn't it? But in this video, I hope you will understand both of them. Okay, let's start lecturing. The first definition of inertia is the object that is at rest will stay at rest unless an unbalanced force acts upon it. Well, I'm going to explain it further, but before that, please watch this video. Okay, now I'm gonna explain it, but because it's not easy to explain it with a ghost video, I'm going to explain it in the real video so you can understand it and you will not be confused. As you can see now, that the boy is pulling the chair and putting it somewhere else. So inertia is something like that. When you move something that is at rest, it is called inertia. At this point, the boy or the ghost touched the chair and move it somewhere else. The chair is at rest and the boy or the ghost is an external force that makes the chair move. Easy? Well, here's the other definition of inertia. The second definition of inertia is the object that is in motion will not change its velocity unless an unbalanced force acts upon it. So that means when you're moving and an unbalanced force acts upon you or you hit it, well, you're gonna stop. Yeah, it's easy as that. Don't make it any complicated. So here's my example and I will explain it later. Now, my video is done. Well, it's kind of funny, isn't it? The noise even matches it. As you can see there, when they're walking when they're running, you can see that they're in motion and nothing can stop it. Either they will bump on the door like the other guy, or they will be stopped by the other person, as you can see when the first boy stopped the second boy. Well, it's pretty much it. Well, it's just a moving object or a thing stops when an unbalanced force touch it. It's like the opposite of the first definition. Okay, now we're finished in inertia. We're going to switch on the second law of motion. It's acceleration. Acceleration is the second law of motion. But, well, in terms of being so easy to hard, it's kind of in the middle because of the formula. F equals to ma. Yeah, gotta remember that or else we're gonna flunk. So, as I can say about acceleration, well, it's only easy as 1, 2, 3. The only thing to remember is the lower the mass, the lower the force to accelerate. It means that you're going fast because you're so thin or you're so lightweight. Well, it goes vice versa with the heavyweight and the fat. Well, to define acceleration more, here is the definition. The change of momentum of a body is proportional to the impulse impressed on the body and happens along straight line on which that impulse is impressed. Whew! Do you get it? Well, I don't. Well, just remember my advice. Lower mass, lower force to accelerate. But I'm going to prove you that I'm right. Even those fancy words, I'm right. There's some deep down that my advice is right. Okay, here's the video and I'm going to explain it further. After that, I'm going to say that I'm right. See, I'm right. The girl wins because she's thinner than the boy. She's faster because of her mass. You should write it down or you should listen to me. So, that's it. But I'm not contented with it. I'm still gonna prove to you that the mass and acceleration are somewhat related. So, here's another video concerning about those two. So here it is, watch it. So now we can see that the mass and acceleration are related because in those two videos, we now prove that the mass is a big deal to accelerate because you know in the first video you can see that the man can pull it even in one finger, but in the second video, wow, if he can pull it in one finger, I may call this Superman. Now it's the third law of motion. Yes, we come to this end and whoo, I hope you really understand all of it. Here is interaction. Interaction is the mutual forces of action and reaction between two bodies are equal, opposite, and collinear. Well, I don't get it. Oh yes, and I'm supposed to tutor you. Well, it's easy when you apply it because, you know, it's easy because in everyday life you use all of these three. If you didn't, well, you're all asleep. Yes. So, here is a video concerning about interaction. And with the help of a certain somebody, I will show you same action and reaction between two bodies. Here is the next video. Okay, I know you're completely clueless of what you saw, but here I am going to explain it to you. So first, why do I clone him or duplicate him? I duplicate him because I want to show you how equal and opposite two bodies react when they put forces on each other. Of course, the wall does not have a man inside it. I just give it just a touch so you can see that they are both pushing each other. I just give the wall an imaginary, you know, figure, and that figure is absolutely him because it's equal but only opposite. I hope you understand it. Okay, my last explanation doesn't end well, right? And I hope this last explanation will do, because this is the simplest way I can tell interaction to you. So here's the last video that I will show you. So I'm going to explain the last video for this lecture. You will wonder why they're only standing. It's because just standing is doing interaction because of the force we're exerting on the floor, and that force is our mass. And when we're exerting something on the floor, it means that it's in exerting something back to us. But we never knew it because it is so balanced, it's all equal, we never even knew it. So that's it. That's the meaning of interaction in the simplest